Greetings, YouTube. Beautiful mind here. I guess that's fine the way that I have it. Um, so this is going to serve as our lecture for week 3. The first of 4 lectures for week 3 for Calculus for Business. Okay, so let's just kind of get into it. We're continuing chapter 1. I think we have 2 sections remaining on differentiation. Okay, so we're just going to keep going with that section, that chapter, and we're going to be looking at section 1.7, the chain rule. Some objectives here. We want to find the composition of 2 functions and differentiate using the chain rule. So again, for our discussion, the derivative is going to be the slope of the tangent line at a point, right? The instantaneous average rate of change, okay? So the composed function f composed g, or the composition of f and g, is defined as f composed g. Give me just a moment. So, trying to get used to this. I have like a new set up here. Oh, let's fix our music too. Yeah, I got a new setup, so I'm just kind of still working out some of the kinks. Anyway, so the composed function f composed g, or the composition of f and g, is defined as f composed g is basically f of g of x. So you have the second function inside the first function. Okay. So for this example, we're asked for f of x equal to x cubed and g of x equal to 1 plus x squared, find f composed g and g composed f, okay? So if we're going to do f composed g of x, this means f of g of x. Okay, let's do g in green, g of x in green. Okay, so this is going to be f of, so then what's g of x in this case? G of x is 1 plus x squared. Okay. So then what's f of x is x cubed, so I'm going to do my x, or replace my x with a blank set of parentheses, and I want to cube it. What color goes into the blank parentheses? The green does. So 1 plus x squared, right? I think I might leave it like that. I'm not going to expand it out. Let me see, what did they do? They did expand it out. We can expand it, I guess. So if we're going to expand it, we'll have 1 plus x squared times, that's going to give us 1 plus 2x squared plus x to the 4. But then we have to like basically FOIL there as well. So 1 times everything is going to be 1 plus 2x squared plus x to the 4. If we distribute the x squared, that's going to give us x squared plus 2x to the 4 plus x to the 6. Okay, ultimately we get x to the 6, 3x to the 4, 3x squared plus 1. Okay. And we'll check on the next slide to make sure that we got it proper. That's fine. Yeah, let's just be consistent. Like this, okay? So then the next one, so we're reversing the order. G compose F of X, all right? So that's going to be G compose, I'm going to do this color. F of X is going to be, this is going to be G compose F of X. But what is F of X in this case? F of X is X cubed. And then G is going to be 1 plus X squared. And we'll replace the X with what color in this case? Fuchsia or pink, right? Okay. Okay, so then this gives us 1 plus 3 times 2 is 6. 1 plus X to the power of 6. Okay. All right, let's see how do we do. Can I favorite somebody? Oh, those are just favorite colors. Okay. So we got, okay, let's see how do we do. You see the first one there and then the second one. See my time? I think we're good on time. Okay. So for f of x is this, g of x is this, find f compose g of x and g compose f. Yeah, the chain rule, okay. So say we're doing the first one, f compose g of x. This means f of g of x, so the second function inside the first function. But then g of x in this case is x minus 1. Okay. And then f is the square root of x, so it's going to be the square root of x minus 1. And I think we can leave it like that. Okay. Then the second one is g compose f of x. That's going to be g compose f of x. Guess we're channeling our AKA energy today, pink and green. All right. So that's going to be g compose. Now f of x in this case is the square root of x. Okay. And g of x is x minus 1, so we could say x minus 1. And we'll replace x with what color in this case? Pink. That's good enough. Let me just copy and paste. Okay. So f compose g, we got the square root of x minus 1. G compose f, we have the square root with the minus 1 on the outside. Okay. So quick check. For these functions in example 2, f compose f, I'm going to leave those as an exercise for you. So then we have the chain rule. So the derivative of the composition f compose g is given by, so the derivative with respect to x of f compose g of x is going to be d by dx of f of g of x. Okay, so the chain rule. Long story short, the chain rule says it's going to be the derivative of the outside function times the derivative of the inside function. So that's all the chain rule is. You just take the derivative of the outside function times the derivative of the inside function. That's the chain rule. So for y is this and u is that, find the derivative of y with respect to u, the derivative of u with respect to x, and then the derivative of y with respect to x. Okay, let's start with dy by du. So the derivative of y with respect to u, so basically just take the derivative, let me see. Okay. So remember that's square root of u is the same as u to the power of a half. So then when we apply the power rule, that's going to be 1/2 u to the negative 1/2. Okay, I'm going to leave that. And then we're asked to find du by dx. So if we do the power rule, let me see, we got this 3x squared, and then the derivative of 1 is 0, right? So then if we want dy by dx, I want to say we can write it like this. Well, long story short, the derivative of the outside function times the derivative of the inside, so we can just say 2 plus 1/2 u to the minus 1/2 times 3x squared. Let me think about it. We probably need to go ahead and plug in our u though. Let me take that a little bit further. Now the u in this case is x cubed plus 1, so we're going to say to the negative 1/2 times 3x squared. Okay. It's a little bit jammed. Let me kind of clean it up some. Times 3x squared. And I'm going to shrink all this onto 1. Okay, let's see, how do we do? We might need to put that negative exponent might need to go into the denominator, but otherwise this should be fine. Let me see if there's anything else. Yeah, let's go with this. So they did move it down. But we got essentially the same thing. 3x squared. Let me see something. Looks like I made a mistake. 2 plus 2. Oh, constant right there. Okay, right here. I'm gonna leave the mistake so you can see it. So this derivative here. Derivative of the constant. I caught it in one, but I didn't catch it in the other. That's so strange. This guy is gone. So this guy is gone. So that guy is gone. Let me go ahead and write the proper. Oh, shoot. So again, this guy is gone, this guy is gone, this guy is gone. So if we account for these changes, and I'll do the updated like this, this is going to be 2 times the square root of u under 1. Then the final result ends up being 2 times the square root of x cubed plus 1 under 3x squared. Okay. Yeah, I'm definitely like trying to move too fast and just making simple mistakes. That's okay. Damn the bricks. And let me box this one. And we also got this one. Okay. So now I think we accounted for our mistakes. So you see that one there, you see this one here, and you see that one there. Okay. All right. I'm going to leave those. Let me see. Find dy by dx. Let me see, how did they do theirs? Okay, yeah. So this is what I was about to write. dy by dx. Hang on. dy by dx is going to be dy by du times du by dx. Okay. So then essentially, like, those cancel. That's not really what's going on. I can't think of the proper way to articulate that, but you know, you can take the result from the first one times the result of the second one, but they both need to be in terms of x. So we need to substitute that u. We need to replace it with the proper substitution. Because if we're doing dy by dx, everything needs to be in terms of x at the end. Let me see. What's my time looking like? We're about halfway. I'm going to leave this as an exercise. If needed, we can work through this together. You know, something of this nature. We'll get practice with this, something similar during class. So example for y equals this and u equals this, dy by dt. Okay. I'm going to try it the way that I think that they're doing it. I mean, what I would naturally do, I would just go ahead and plug in, do the substitution, replace u with the 5t minus 1, but then we would get like a kind of a bulky result. So I'm going to try it the way we just did the last one, right? So first let's find dy by du. dy by du, right? So the derivative of y with respect to u. That's going to become 2u minus 3, right? Then let's find du by dt. So the derivative of u with respect to t, okay, that's going to be 5, right? So then dy by dt is going to be dy by du times du by dt, okay? Hopefully I'm not articulating that incorrectly. So then basically that's going to be 2u minus 3 times 5. But what we need to do, everything needs to be in terms of t, so we need to make that substitution. So then this is going to be 2 times 5t minus 1 minus 3, and then all of that times 5. Let's expand this out. I guess this is a little bit easier than what I was about to do. I feel like this is easier. Just do them separately and then do the substitution at the end. Let me distribute. So if we distribute the 5, that means a 10 is going to be going into here. Oh no, my battery is low for my pencil. And there's going to be a 5 times this guy. All right, hopefully that makes sense, okay? So that's going to become 50t minus 10 minus 15. Ultimately, we'll get 50t minus 25. Let's see how do we do. We'll come back and fix it if we got something incorrect. Okay, 50t minus 25, and you see it there. 50t minus 25. So again, first they did dy by du, they get this. They did du by dt, they got 5. So then the derivative of the outside function times the derivative of the inside function. So then 2u minus 3 times 5, but then they had to do the substitution. So they got this, then they did the substitution. Long story short, they got the same result. Man, I'm feeling like pretty good. Like I finally got back out and like did some running today, so I feel really, really good. Anyway. Let's see, we're almost done. Let me see, I got about a little over 10 minutes here, maybe more like 15. So then the extended power rule, suppose that g is a differentiable function of x, then for any real number k, so d by dx of a function to a power is basically chain rule. So the power comes down, you subtract 1 times the derivative of the inside function. All right, so this is still essentially the derivative of the outside function times the derivative of the inside function. So we're actually differentiate here, okay? So then f prime in this case is going to be, so the exponent comes down, that's going to be 1/2 times, you got this 1 plus x cubed, then it's going to become to the power of a negative 1/2, and then we're going to say times the derivative of the inside function, which is just going to be 3x squared, right? So then we can like write it in the form, we're going to have the square root 1 plus x cubed is going to be 2 times that. That's on the bottom. On top, we have 3x squared. And I think this is the final result based on the way we've been doing everything else. Okay, let's see, how do we do? 3x squared, okay. 3x squared, then they got the same thing. Okay. Let's do this one. Oh, we got a couple of rules here. We got the chain rule, we got the product rule simultaneously, right? Okay. So then f prime in this case, so the product rule goes the derivative of the first function times the derivative of the second plus the second times the derivative of the first. So then the first function is going to be this 3x minus 5 to the power of 4 So the first times the derivative of the second, I can go ahead and take the derivative. So that's going to be a 10. We're going to have 7 minus x to the power of 9. And then, I guess times what, a negative 1? Because you got to do the chain rule, the derivative of the outside function times the derivative of the inside function. So that's the first half. Then I'm going to say plus. So the first times the derivative of the second plus the second, which is this guy, times the derivative of the first. So that's going to be a 4. The 3x minus 5 is going to be persist, power to the power of 3, and then times the derivative of the inside function is just going to be 3. Okay? I know we're not going to expand those out. Like, there's no way we're going to do that. Can we do have some like factors we can? I think we have some like terms that we can factor. They both have the 3x minus 5 and the 7 minus x. Okay, so I'm going to write this in factor form. Think about it. Okay, so we can factor out a 3x minus 5, and we can factor out a 7 minus x from both terms. Both of them have at least 3 of this guy and what, 9 of this guy. Now if we pull those out from both, what does that leave us with? So the first one, we still have a 3x minus 5. There's still what, a 10 and a negative 1, right? The second one, we still got a 4 or 3. I'm gonna run out of space here. And we got a 7 minus x. Okay, a little bit jammed. Let me write this better. So that's gonna be 7 minus x. Am I missing anything? 4, 3. And then what I'm gonna do is put all this on one line. Okay, I think there's one more step for this one. I know it's a little bit intense. Let's do one more. So then, finally, we're gonna have 3x minus 5 to the third, 7 minus x, that's not a minus, 7 minus x to the 9. That's gonna become, if we distribute that negative 10, that's gonna give us, like right here, we're distributing a negative 10. That's going to give us negative 30x plus 50, okay? In the second one, we're going to distribute a 12 here. And I think I need another set of parentheses here, okay? We're going to say plus, let me see, 70 plus 14 is 84. So it's going to be 84 minus 12x, okay? One more step and I think we're done here. 3x minus 5 to the power of 3, 7 minus x to the power of 9. If we combine like terms, what is that, negative 42? Negative 42x, 134, 134. Okay. You could probably factor something out of those, but I'm just gonna, I mean, if we took out the greatest common factor there, 84. I don't feel like crunching that number. There is one more factor. We can factor a little bit further, but I'm just going to go with this for now. So I'm not like going back and forth with this so much. And we're at 24 minutes. Okay. Let's see, how do we do? Yeah, was it just the 2? Did you get a negative 21x? Okay, and a 67? Okay, we can do that. Well, and some said just do the 2, and I ignored it. Anyway, I got where I wanted to be. So 3x minus 5, you see it here, to the power of 3. Okay. 7 minus x to the 9. Okay. And then if we factor out the 2, we would have 67 minus 21x. So if we factor out the 2, it's going to be 67 there. And 21. Okay. my bad. We did kind of leave one little thing, but it's okay, I think. So yeah, I took some time. I was trying to figure out how to get this audio. Instead of playing audio from a speaker, which I knew it wasn't going to pick it up that well, and I listened to him, I was like, okay, I got to fix this audio thing. It took some finagling, and like it took the better part of my Saturday to figure out, okay, how do I get this to work? I mean, research, like finagling, like it took a lot. But I think I got it. It seems like it's working. I can hear the audio and I can record, and it's a feed instead of, you know, the background noise of the speaker. It's a direct line. So, and it's all on the computer. I was like, man, I didn't have to get any other devices or anything. And it's all free. I was like, that's awesome. I'm just geeking about that. So example 6, differentiate. Oh yeah, we just did that one. Okay, on to the next one. Let's see. And then it's a quick check. That one's using the quotient rule. So remember, the quotient rule was low D high minus high D low over low low, right? So you're going to be doing the quotient rule in conjunction with the chain rule, right? So that was a little bit, takes work. With these, my recommendation is to like give yourself plenty of space, take your time, a big, clean, open, white space, and just take your time. If you make a mistake, either throw it away. You want to have something clean, because it's very easy to get lost in the algebra here, right? Because it's just so much. You just want to be neat and organized as much as possible. Let me see my time. Okay, we got it right under 10 minutes. That's a summary. Okay, so I want to do one more. I'm going to try this one, this quick trick, and this will be the last one for this section. So I'm just going to do it. Let me get a copy. Get rid of that one. So I'm going to take this one, and I want to actually do it myself. I know we got the result there, but I want to just give it a go. So we're just going to do this one to go, and then we'll wrap it up after this one. Let's go paper. Okay. So we're asked to differentiate. Okay. So if we're going to do f prime, I realize I need to charge my pen. F prime is going to be the low D high minus high D low over low low. So the bottom, which is going to be 3x to the 4 plus 2 squared times the derivative of the top. Fortunately, there was no powers there, so it's just going to be, well, 4x. So the bottom times the derivative of the top minus the top, which is this guy, 2x squared minus 1, times the derivative of the bottom. So we got to use the chain rule. I'm going to drop down because I'm going to run out of space. So the chain rule is going to be, I'm going to put my times there. So it's going to be 2 times 3x to the 4 plus 2. The exponent becomes a 1 times the derivative of the inside function. So that's going to be 12x to the 3. I think that's it there, right? This is all the numerator. I'm going to go like, I'm going to do like this. I'm going to rearrange this so that it's all on one line momentarily. So the bottom, let me see. The bottom times the derivative of the top minus the top times, this is all the derivative of the bottom over the bottom squared, right? So, and I'm going to put it all in one line. So the bottom squared is going to be 3x to the 4 plus 2. It's going to be now to the power of 4, right? Let me shrink this down and just get it to the presentation to look a little bit better. Let me see my time. We're good on time. So I want this guy. Back. Okay. So then next is just simplifying, expanding what we think we need to expand. Now, So if we look at the top, notice we got a 3x to the 4 plus 2 there. We got a 3x plus 4, a 3x to the 4 plus 2 there. So we can factor that out of both terms. Let's factor that out. They both have at least 1, right? So before we expand it, let's factor. So then this is going to be equal to, we got this 3x to the 4 plus 2. They both have 1. Okay, what's going to be left over? The first one, I'm going to go ahead and distribute. 4 times 3. It's going to be 12x to the power 5 plus 8x. Okay. We took that out, so that one's gone. And then what's left over? Okay. So we're going to have minus. Now we're distributing again. What's that? 24x to the 3. So we're distributing a negative 24x to the 3. So that's going to become, let me see, negative 24x to the 3. So is that 48? So that's going to be a minus 48x to the 5 plus 24x to the 3. Okay, I think that's it. It was just those two terms. It's a little bit intense, right? You just have to take your time, space it out, and do your own thing. I think we're almost there. So then we get this 3x to the 4 plus 2 to the power 4, right? Let's go ahead and do our cancellations. So because it's now in factor form, this can cancel at least one of those, turns that into a 3. Let me see. 12, what is that? 48, so 38, 36, so negative 36. X to the 5th. 24, x to the 3rd. Then plus 8x. Now we could factor out at least a 2. What does that become? 18, 12, so we can do 4. We could factor out a 4 from everything, 4x. Okay, let's do that. It's not going to cancel anything, so I'm not sure that we really need to do it, but so the 3rd. But we can factor out a 4x from everything there. Let's just kind of compare it to what the notes did. They left it. See, that's why I paused. So minus 36x to the 5th, 24x cubed, plus 8x. That takes practice. 3x to the 4th. The main thing I wanted you to see was how we saw, I'm gonna leave this highlight for you all, hopefully it helps. How we identify, oh, there's a 3x plus 4 there, and there's a 3x to the 4 plus 2 there. They both had this, right? And then it was in the bottom. So sometimes with these, it's just, you have to be aware to look for that factor. And it's not easy to catch, because if you try to expand that, it's very easy to miss that factor. That's why I was like, well, let me just do it and try to bring it to your attention as best I can. Okay, I'm looking at the time. We're right at 34 minutes, and that's exactly what I wanted. Let me go to paper, get rid of my lines there, and that's essentially what I wanted to do with that section. Okay, a little bit intense. Just do your best. And on that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day. Peace.